All right, so we're going to start off this week looking at section 1.3. And 1.3 is on what we call functions. So it's kind of a little refresher. We had done a problem in the last section on renting a car. And I think it had cost 20 cents per mile you drive the car. And there was a $15 fee that you pay one time when you rent the car. If this was like a y equals mx plus b equation, the 0.2 is the m, and the 15 is the b. Does anybody remember what you call the m? Yep.
Slope.
Yep, that's the slope. And the slope is always like a fee that you have to keep paying. Whether it's like you're selling tickets at a concert and you want to keep track of sales, like tickets were $10 each, 10x would be the formula. It's always the thing that is changing, or you have to keep adding up. This number at the end, the b, that's the, what do you call that one?
The y-intercept?
Yeah, that's the y-intercept, and that's usually like a one-time fee. Like if you got to pay, let's say like you're renting a car and you pay $15 to book the reservation, or it's like a non-refundable type deposit. You pay one time. Now the x and the y, I think we talked about what those were called. One of them is called independent, and the other one was called dependent. Does anybody remember which one the x is? Yeah?
Independent.
Yeah, independent. So there's different names for the x and the y. Okay, there's three names. Calling x the independent and y the dependent, that's one pair. You can also call the x the input, and the y is called the output. Because when you pick a number to fill in, usually you fill in a number for x. That's the number you're plugging in for. That's why they call it input. Then there's some arithmetic you do, and then you get an answer out from the formula. That's why it's called the output. Okay. Two other terms we'll use quite a bit are domain and range. So domain are all the numbers that you are allowed to plug in. Range are all the answers that you get when you do the arithmetic out in the formula. Now, with some formulas, we do have to be careful what we plug in. So like in this case, if x represented the number of miles that you drove the car, what kind of numbers wouldn't make sense if you were plugging in a number of miles you drove the car? Yeah?
Negative number.
Yeah, you wouldn't be plugging in negative numbers. Okay? It's not that algebraically you can't do that. I can plug in negative 106 and tell you what it comes out to. It just doesn't have any meaning in the problem. Okay? So sometimes we have to be careful with the numbers that we are plugging in. All right, so what makes something a function? In order for something to be a function, you have to have a formula where you plug in a number for x and you get exactly one answer for y. Okay, you might think, isn't that every formula? You plug in a number and you only get one answer? No. Let me show you something that is a function. If I plug in 1 for x in that equation, y equals 2x plus 3. If I plug in 1, what will I get for y? Yeah.
5.
Yeah, I'll get 5. Is there any other answer I get for 5? Then 5. No. If you plug in 1 for the input, you will get exactly one answer for y. You will get 5 and only 5. Let's look at this one. Y equals, let me write it this way. Let's do y equals positive or negative square root of, let's do 8x. All right. If I plug in 2 for x here, what's 8 times 2 give me? 16. And what number times itself that's positive gives me 16? 4. So if I plug in 2 for x, I get 4 for y. All right, let's do it one more time. I'm going to plug in 2 for x again. So 8 times 2 is 16. Now what number times itself gives me 16 and it's negative? Negative 4. So if you plug in 2 for x, you will get the square root of 16. But there are two answers to that, positive 4 and negative 4. So this is not a function because you plugged in one number for the input and you got 2 different answers. It's not a function. Okay, so any question why that top one was not a function and the bottom one was? Okay, so functions have only one answer when you plug in a number. I kind of already said that to you. Domain, those are all the numbers that you're allowed to plug in. Range, those are all the answers you get from the formula after you plug things in. Okay, unless the problem says otherwise, when we deal with domain, the domain has to be a real number. Okay, what's an example of something not a real number? Will be imaginary. Okay, we might talk about imaginaries a little bit later on, but for now, everything is going to be real numbers. Okay, so when we talk about domain, there's really two kind of ways of thinking about it. Domain are the numbers you are allowed to fill into a formula. So let's put that formula we had up again. When you have numbers and you're looking, can I plug them in? Right? Whether or not you can plug them in depends on what you're kind of thinking about. Are you talking about can you plug it in because it makes sense or doesn't make sense in the word problem? Or are you talking about if you try to plug it in, like if you did it on the calculator would give you an error. Like you're trying to plug in a number that wouldn't even work. In this problem, any number could technically be plugged in for x. Positive, negatives, fractions, decimals, 0. And you could do the arithmetic out and you'd get an answer. When we talk about domain in this problem, we're talking about it more practically in terms of the word problem. You wouldn't want to plug in negative numbers because it's mileage. It just doesn't make practical sense. Compared to when we look at something like this, there's a number that we can't fill in for x there, not because it doesn't make practical sense like in terms of a word problem, but if you fill in this number, you can't do that calculation in math. Like it's just something you're not allowed to do. So does anybody see a number that you cannot fill in for x there? Because if you did this, you'd be doing something you're not allowed to do. Yeah? 1. Well, if you plug in 1, you'd have 3 divided by 1 minus 2. 1 take away 2 is negative 1, and 3 divided by negative 1 is negative 3. So if you plug in 1, you're okay. You can plug in 1. Yep.
0.
Well, if you plug in 0, you'd have 3 divided by negative 2. That's okay. You can do that calculation. Yep.
2.
Yeah, why can't you plug in 2?
Because 2 minus 2 is 0.
Right. Right. If you try to plug in 2 into the bottom, you get 2 minus 2 is 0. And then if you try doing 3 divided by 0, it says you can't divide by 0. So the domain in this problem would be anything you want for x except the number 2. You can't fill in a 2 because in math you are not allowed to divide by 0. So that's one thing we have to be very careful with when we talk about domain. If there's a number that could cause you to divide by 0, we have to say don't use that number. Okay? Now, in this one, is there anything I could plug in for x that would cause me to divide by 0? You think, Ricky?
I don't think so.
No, because it's not a fraction. Okay? In order to divide by 0, you'd have to have a fraction with a letter in the bottom. This doesn't have a fraction with a letter in the bottom. So that issue that happens here would never happen here. Okay, and let's look at this one. Square root of x minus 3. When you have square roots in a problem, that's something else we have to be careful with the derivative. We're dealing with real numbers. So when we take square roots, if you want to get an answer that's real, does anybody know what we have to make sure the square root underneath the square root is? Like, this has to be a certain kind of number. If it's not that kind of number, then when you go to take the square root of it, it's going to come out imaginary. Yeah?
Oh, that's positive or 0.
Yes, it has to be positive or 0. If you try to take the square root of a negative number, the calculator is not telling you that it can't do it. It's just telling you the answer is not a real number. And for now, we're sticking with real numbers. So we would have to make sure that what I circled right here is always 0 or higher. So anybody think they know what kind of numbers I could fill in for x that would make sure what I circled is always 0 or higher? Can't be below 0. Yep.
I'll say 12.
All right, you could plug in 12. Yep, that works. But you could also go lower than 12. How low could I go? I can't go too low. Like if I go down to 0, that's too low. Because 0 minus 3 is negative 3. Now I have a negative number. That's no good. Yep, 3. I can go down to 3. So you are allowed to plug in any number 3 or higher for x. Some people mix up taking the square root of 0 with dividing by 0. Square root of 0 is fine. You can take the square root of 0. You can't divide by 0. All right. So the domain in this one would be any number that you want, 3 or higher. And when we say any number, I mean literally any number higher than 3. 3.00462157. I mean anything higher than 3 or equal.
So if you were to like write it down, it'd be domain is greater than or equal to 3.
Right. We're going to talk about different ways we would write that, but yeah, it would be, if you wrote it in words, it would be the domain is every number greater than or equal to 3. Yep. And we'll talk about shorter ways we can write that. But those are the two big things we have to watch out for. Dividing by 0, square roots of negatives. All right, so when I wrote this function, I wrote y equals. Well, there is another notation besides doing y equals, and it's like this f parentheses x. Okay, that's not how you say it. Does anybody know how you pronounce what's on the left side? Right there? Yep.
F of x?
Yeah, you pronounce it f of x. It's just a different notation rather than writing y equals. So why do we use it? Well, then I could do something like this. And I could say, all right, I want you to put f of x in on your calculator. If I just called this one y equals and I called this one y equals, there's nothing to really separate them. Unless I say, well, look at the one that has the 15 on the end. You know, it's just more, it's more complicated for me to explain which one I'm talking about. So now I could say, put in f of x, put in g of x. So it gives us a way to differentiate when you have multiple equations. The graphing calculator doesn't do that. Okay, it does have a way to differentiate it. It uses these little subscripts, y1, y2, and so on. Okay. So any question on that notation? Okay. No, well, this is kind of like the one I just actually had on the board. Well, I'll just do it anyway. So it says find a complete graph. Gives us the square root of x minus 3. And then it asks us to find the domain and the range. Domain is usually, that's the easier one. Okay, all we got to check for is, can we divide by 0? Could we take the square root of a negative? We need to avoid those two things. When we get to range, that's where we'll do it on the calculator, and look at a picture. All right, so let's take that in. Okay, so on the calculator, remember you got to turn it on first. Press the y equals in the upper left. If there's anything in there, we press clear. Anybody have trouble getting to that screen? Okay, so we're going to press second, and you're going to press the x squared button. That's how you get your square root. We're going to do x minus 3. Now, normally at this step, I would say, okay, we got to figure out the domain, but we just figured it out. It's the same question I just gave you a minute ago. It was all numbers that were 3 and up. Does anyone have a question why it's all numbers 3 and up? So when I press window, if I need to look at numbers that are 3 and up, I don't need to go all the way to -10. I'd say I like to go a little bit more, so maybe we'll go as low as 0. And let's go as high as 100. Okay, so we'll set the x max at 100. Let's hit graph. So there's my square root function. Yeah, a square root always looks like a sideways parabola. That's what it looks like. So it's a parabola, just half of it on its side. All right, so let's talk about how we can write the domain. One way we can write the domain is start with the letter that represents domain. That's x. And x has to be greater than or equal to 3. So that's one way you can write the domain. All right. Let me show you another way. If x has to be greater than or equal to 3, what's the lowest number you can pick? 3. Yep, so 3 is the lowest. So low, comma. Now we're going to put the highest value you can pick. What's the highest value you could pick? Infinity. And remember, there's 2 types of symbols. Did we talk about bracket and parentheses last week? Yeah. So remember, bracket means you can include the number. Parenthesis means not included. So we have to put brackets and parentheses on that. So start with the 3. Is it okay to include the 3, like to be equal to it? Yeah, because it says right here, equal to. So we can include the 3. Now, infinity. Can we reach infinity? No, if you can't reach it, then you can't include it. All right. So anytime you have an infinity symbol, that always gets a parenthesis. There's 2 different ways to describe the domain. The top one is called an inequality. The bottom one is called an interval. If the directions don't say which way, you can do it either way. If on the test it says describe using an interval, then I'd be looking for the bottom one. Okay. All right. Now let's try to do the range the same way. Okay, so let's look at our graph. Domain is left and right. So this graph starts at 3 and it goes to the right forever. Range is up and down. What does it look like the lowest that the graph goes is as it starts coming down? Yeah, the lowest it ever goes is 0. And if you want to do zoom to, you could zoom in. You hit enter. You can see it. Sometime when it starts to get really steep, the calculator has a little trouble drawing it. But this should really come down all the way. Okay, so the lowest that it goes is 0. What's the highest that this graph is going to go? Yeah.
Infinite?
Infinity, yeah. It's a sideways parabola. So sideways parabola is just going to kind of it's just going to keep getting wider and wider and wider and wider. It's never going to stop going up. It doesn't go up as steep as it did at the beginning, but it does keep going up. It never flattens out. All right, so anyone have a guess how you would say the range for this one? And let's say it this way. Let's do it the top way. Anyone think they could give me the range? Lewis? And remember, the letter now is different because it's range.
Y is greater than or equal to 0.
Yep. Y is greater than or equal to 0. Okay, that's an inequality. Now let's try it as an interval. Okay, what's the lowest number you could pick that's greater than or equal to 0, Ricky?
0.
0. What's the highest number you could pick? Infinity. Can we ever include infinity? No, because you can't reach it. If you can't reach it, you can't include it. It just goes on forever. And now the 0. Can we include 0? Or do we not include 0? We can what?
I would say
Oh.
we can include it.
Yeah, we can include it because it says equal to. If that equal to wasn't there, I would have put a parenthesis. Okay, so everyone understand that's two different ways of answering the question. You don't need both. It's one or the other. All right, any questions on that? Yeah.
On the quiz, will we just see one of them?
There'll probably be both, but it wouldn't be in the same question.
Okay.
Like one question I might say, find the domain, write your answer as an inequality. Then the other one might be like, find the domain, write your answer as an interval. And a lot of people will get this one on the test, and they'll be like, how do I type in the less than and greater than sign? I say, well, read it again. It says interval. You never use less thans and greater thans when you do intervals. You use brackets and parentheses. So generally, if you're taking the test and the symbol isn't available for you to use, it's probably because you don't need it on that question. All right, let's try this one. Okay, find the domain and the range. All right, so to find domain, we're just going to ask ourselves two things. Does this problem have a fraction with a letter in the bottom? Nope, so we don't have to ever worry about dividing by 0. Does this problem have the square root symbol? No. It doesn't have either of the two things that could cause a problem. That means you can plug in any number that you want. If you can plug in any number that you want, what's the lowest possible number you could plug in?
1.
Infinity.
Well, infinity will be the highest.
Negative infinity.
Negative infinity.
There we go.
Okay, so writing that, that's a way to say all real numbers. Anything you want. And practically, if you think about it, you can take any number you want and raise it to the second power. Positives, decimals, negatives, doesn't matter. Okay, so that's the domain. Yeah, range, that's the one where usually we draw a picture. And let's take a look at that. So it's x squared minus 4. Since I changed my window last time, I'm going to do zoom 6. Get it back the way it was. And you can see that as you zoom out more and more, the parabola is just going to keep getting wider and wider. So it will go left and right forever. That's why the domain is all real numbers. But it doesn't go up and down forever. What does it look like the lowest that graph goes is?
-4.
Yeah, -4. And what does it look like the highest it goes? Infinity. Yeah. The lowest is -4, and the highest is infinity. Okay, we never reach infinity. And it will reach -4, like if you plug in 0. When x is 0, you are down 4. And you can check that by, if you're on your calculator, and you hit graph. If you hit trace, it'll tell you when x is 0, y is -4. Actually, I think you can type in any number you want, and it'll tell you what y is. You have to press trace first. All right, so since we actually hit -4, would I use the bracket or would I use the parenthesis?
Bracket.
Yep, I'd use the bracket. So there's your domain and range. All right, let's try almost the same question, except I want to put the x minus 4 in absolute values. What does absolute value do to a number?
Makes it.
Right, it's going to make it positive. So what that means is anywhere where the graph would have tried to become a negative, that part is going to get kind of flipped up like that. Okay, so that negative part will not be allowed to go negative. It's going to be flipped up. Let's graph that. It's probably easier to just retype the whole thing because there's not that much there. So I'll just clear it. To get to absolute value, you have to press math. And then you'll see different menus across the top. You're going to press right once and go to number. And the first option says ABS. That's absolute value. So math, then press the right arrow, and then press enter. All right, and now type in exactly what you see right there. X squared minus 4. X squared minus 4. Okay, so again, where it tried to go negative, the absolute value didn't let it. It took that part and it flipped it up. Okay, so looking at the domain, any fractions with letters in the bottom? No, you still don't have that. Any square roots here?
No.
No. So what's the domain? Yeah?
Negative infinity, positive infinity.
Yeah, the domain doesn't change. There's no change at all. You can still plug in any number you want. Bless you. Okay, but the range is different. It's not -4 and up. What does it look like it is now? 0 and up. So the lowest that the graph goes is 0, and the highest it goes, it just keeps going up forever. And you will actually hit 0. Does anybody see what number you'd have to plug in to get 0 there? Well, if you plug in 4, you'd have 4 squared is 16, and 16 minus 4 doesn't give you 0. 2. Yeah, if you plug in 2, 2 to the second power is 4, and 4 take away 4 is 0. So it hits 0 when you go over 2 to the right, and it also hits 0, yeah, at -2. Yeah. So it hits it twice. So we actually hit 0, and it goes up forever. It takes a little practice to get good with domain and range, but the calculator can really help you a lot with the range. Okay. Any questions on that one? Okay. Just sign back in for me. All right, so next thing we're going to take a look at, it's actually a lot easier than domain and range, is what we call evaluate. Evaluate means that they give you a number and you plug it into the formula. So when I ask you to evaluate something, I'll always give you a formula, like that, and then I'll give you something that I want you to plug into the formula. Like that. I might give you a number to plug in, could give you a letter, or a number and a letter to plug in at the same time. Generally, when you plug in a number, the answer that you get will be a number. When you plug in a letter, the answer that you get will have a letter. Does everyone have that top part to find f of x? Okay. So let's start with f of negative 2. That means I'm going to look up the formula f, and everywhere that I see a letter in that formula, I'm going to change it to whatever they give me inside the parentheses right there. Okay, so the first thing we're going to do is plug in a negative 2 everywhere we see an x. So fill it in right there. So negative 2 squared plus 1. All right, Christian, what's negative 2 to the second power?
Let's be
4, and then plus 1? 5. Now, if I check the answer on the calculator, how come if I do negative 2 squared plus 1, it gave me negative 3? Yeah?
Because it's only squaring the 2 and then adding the negative to it.
Yeah. It's just squaring 2, getting 4, throwing a negative in front of it, calling it negative 4, and then adding 1. Okay. Anytime you want to square something that has a negative, or anytime you want to raise anything to a power that has a negative, put it in parentheses. And then you'll get the right answer. All right, so that's f of negative 2. All right, let's try f of a. Anyone think they could tell me what you'll get when you plug in a for x? Yeah.
Would it just be a squared plus 1?
Yeah, that would just be a squared plus 1. There's nothing else you can do with it. Just replacing the letter in the formula with what's inside the parentheses right there. Right? And the last one we're going to do is f of x minus 3. So everywhere you see that letter, we're going to replace what I just circled with x minus 3. So it's x minus 3 to the second power plus 1. Now, that one, depending on how they ask you to write the answer, that one can be simplified. Okay. X minus 3 to the second power, what does that mean when you raise something to the second power?
Multiplying by itself.
Multiplying it by itself. Okay, so that means to do this. Multiply x minus 3 by itself. Okay, and in algebra, you learned a way to do that. Okay. Some people call it FOIL. Some people call it like the distributive property, but it's twice. But that's how we have to do it. Okay, so let's start with what's x times x?
X squared.
X squared.
Yep, x squared. And what about x times negative 3? That's negative 3x, and then another negative 3x. What's negative 3x and negative 3x?
Negative 6x.
Yep, negative 6x. And what's negative 3 times negative 3?
9.
9. Don't forget about your plus 1 that was up there. So what do you think we'll get for our final answer there? Yep.
X squared minus 6x plus 9.
Yep. Perfect. I'd say most of the time that's how the book would leave the final answer. Okay, they'll FOIL it out, distribute it out. On a test, I would always let you know. Okay, if I want you to do it out or not do it out. And if the directions ever don't say, you can always ask me and I'll let you know. Questions on that? All right, so that's evaluating. Okay, so not every equation that we look at is a function. Okay, I told you guys earlier that every time you plug one number in, you have to get exactly one number as the answer. Well, there's a way to visualize that, and it's called the vertical line test. Okay, what I gave you earlier, that is the formal definition of a function. This is kind of a way to visualize it when you're starting out. And the idea is if you have a graph, like let's say you had a circle. If you can draw a vertical line and it hits the graph in more than one spot, then your graph is not a function. So in that case, I can put a vertical line right there, hits it twice, that means a circle is not a function. Let me draw, I don't really spend a lot of time on this because there's not much more to it than that. Let's say I had a wave like that. And I draw a vertical line. Does this vertical line ever hit the graph more than once? No matter where I put it? No. So that's a function. That's fine. What if I had something like this? It's kind of a wave, but now it's on its side. Does this vertical line ever hit more than once? Yeah, it hits it a bunch of times. Yeah. So the vertical line test is a quick way of figuring out if you have a picture, if it's a function. Any question on that? Okay, sometimes I'll abbreviate that like VLT, vertical line test. All right, so here's another one, just finding domain and range. All right, let's try that. Okay, first, for domain, ask ourselves two questions. Any fractions with letters in the bottom?
No.
No. Are there any square root symbols?
No.
No. So then what do you think the domain is going to be?
All real numbers.
All real numbers, yep. If you don't have either one of those things, then we don't have to worry about any issues with the domain. Okay, range. What do we usually use to help us find the range? Yeah, we're going to use a graph.
Okay.
So let's type it in. Okay, go to y equals. Type in 16x minus x. And then to do the exponent of 3, you're going to press the button right below clear. And then press the 3. And that'll give you x cubed. Let's do zoom 6. And remember, we're looking for how high and low the graph goes. Okay, so looks like the graph kind of does some turns, but can we see them on the screen?
No.
No. So what I'm going to do is I'm going to zoom out a little bit. What do I need to set higher and lower to see where the graph turns? Yeah, I would set the y min and the y max higher and lower. So let's set like the y min. Oh, let's try like negative. Yeah, you could try a different value. I'm going to go negative 50 just because I don't want to keep trying it all day. All right, and I'm going to do a y max of 50. Just to see if I can see it on the screen a little better. Yeah, that's good. Okay, so I can see where it turns, but does the graph go past where it turns? As far as up and down. Yeah, it's definitely going past it. How high do you think it's going to go? Yeah, you could zoom out more, and you could look at it. Like you could go like negative 100 to 100. It's going to make it look a little more squished because I'm zooming out more. But is that graph showing any signs of turning again? No. And it's not going to. It's just going to keep going up, and it's going to just keep going down forever. So what do you think your range is? Your range is also negative infinity to infinity. Yep. Any question on that one? take a look. We're not going to do that one. We're going to do a different one. All right, so next, I think this is the second to last thing we're going to take a look at. Yeah, it's called projectile motion. So projectile motion is basically when you throw an object and then gravity takes over. All right? So it doesn't have any kind of motor or like rocket on it that propels it. You just throw it, gravity takes over, and you could look at the path that it makes. It looks kind of like a parabola. That's what it looks like. And there's a formula that we use when we do projectile motion, and that's the formula. It's negative 16t squared plus v sub 0 t plus s sub 0. These two things that I just put boxes around have to be given to you in the problem. This negative 16 is always negative 16. It has to do with gravity. So if you went to another planet, then yes, the negative 16 would change. But as long as we're on Earth, we're going to use negative 16. The v sub 0 is how fast this object was thrown or launched. Okay, it's the speed right when it was launched. And s sub 0, that's what we call the initial height. So in other words, when you threw this object, were you standing on something when you threw it? So you were already like 5 feet off the ground? Were you on top of a building that was like a couple hundred feet tall? What was the initial height when you threw the object? And in our problems, we will always be using units of feet and seconds. In like science, probably not the units you would use. They're probably going to use like meters. They'll use metric. And if you use metric, that does change a few things, but we're not going to worry about that. And on the test, you can have a reference sheet. So if that's a formula that you don't remember, I would probably write that down in case you had a question on projectile motion. All right, so let's take a look at a problem. So we have a rocket that we are shooting straight up. From ground level. What does that tell you about the initial height?
0.
Yeah, it's 0. So it's just going to be like a plus 0 on the end. And the initial speed of the rocket is 64 feet per second. Now, if we look back at that equation you just wrote down, you look through the whole thing, what's the highest exponent in that whole formula? It's a 2. Okay? When an equation has a highest exponent of 2, that makes it a quadratic. Okay, so a quadratic it's like one step up from y equals mx plus b. Y equals mx plus b is linear. When we have a quadratic, sometimes we have to solve it by factoring. Sometimes we have to solve it with the quadratic formula. And we'll review that if we come up to a problem where we need to do it. Okay, so it says, at what time will the rocket be 50 feet above the ground? So let's look up at that formula, and I want to see where I would plug in the 50. At what time will the rocket be 50 feet above the ground? Where would that 50 get plugged in? Remember, it's the height. So we have to look where the height is in that problem. Yeah?
The S of t.
S of t. It says right here. the height, s of t. So that's where your 50 is going to go. What about initial velocity? What number are we going to plug in for that? 64. And initial height, we already talked about. We're going to plug in 0. So let's fill everything we can into that formula and then see if we can solve it. So we get 50 equals negative 16t squared plus, and fill in 64 for the initial velocity. So that's the equation we have to solve, and it is a quadratic because it has an exponent of 2. When you are solving a quadratic, you always want to get it equal to a certain number. Does anybody remember what you would want on this side when you're trying to solve it? Yeah?
0.
Yeah, you always want to get it equal to 0, whether you're going to try to factor it or use quadratic formula. How would I move that 50 to the other side?
Minus 50.
Minus 50. Okay, so this part, just going to move that up. I'm going to do using the quadratic formula. There's 3 letters in the quadratic formula. Anybody remember what the 3 letters are they use that we have to plug in numbers for? Yep.
Was it just A, B, and C?
Yep, it was A, B, and C. A is always the number that's in front of the variable squared. B is the number that's in the middle, just in front of the letter. And C is the number that's at the end. Okay, now, if you don't remember the quadratic formula, let me show you what it is. It's negative b plus or minus the square root of b squared minus, does anybody know the part that comes after the minus? Yep. 4.
AC.
Yep, AC. And the last thing is everything is divided by, yeah, 2a. So we just have to fill in our numbers. They're going to get big, but that's why we're going to use the calculator. So b is 64. So negative b plus or minus 64, and I need to raise that to the second power. Let's take 64, raise to the second power. No, it's not that big, but 4,096. Minus 4 times A times C. A is negative 16. C is negative 50. We're going to divide that by 2 times A. What's 2 times A going to be? Negative 32. Okay, so what I want to do is I want to simplify what's under that square root just so I don't have to deal with all of that. So it's 4,096 minus 4 times negative 16 times negative 50. Okay, so as long as I type that all in right, I think we're okay. Should be 896. Now, there's a plus or minus. Why would there be 2 answers when the rocket hits 50 feet? How can the rocket hit 50 feet more than once?
Coming back down.
Yeah, it's going to come back down. So it's going to go up. It's going to hit 50 feet on the way up. And then when it comes back down, it's going to hit 50 feet again. That's why it hits it twice. Okay, so let's type it in. Negative 64 plus the square root of 896. I'm just going to do the top first. And then I'll divide by negative 32. Okay, so I get that, and then divided by negative 32. So that's about 1.06 seconds. Is at one point where the rocket hits 50 feet. Since that's only after 1 second, that's probably on the way up, because that's pretty soon after it launched. 1.06. And, let's type it in again, negative 64 minus the square root of 896, and then I'm going to divide by negative 32. 2.94. So that's probably now on the way back down. 2.94. If they ever don't say how many decimals, I'd say 2 is usually pretty good. Okay, so it's just kind of a review of quadratic formula. It's pretty straightforward as long as you know the formula and how to identify the A, the B, and the C. I can write that down over here just in case. A, B, C. Okay, any questions? Now, for the next part, I want to use the calculator. It says, basically, how high does the rocket go, and when does it reach that maximum height? Okay. So for that, I'm not using the 50 feet. That was part of it. I don't care when it's at 50 feet. I want to just look back at the original formula that I had. Negative 16t squared plus 64t. Let's type that in. Under y equals, put in negative 16t squared. You do have to use x. You can't use t. It's negative 16x squared plus 64x. Now remember, x represents time. Could the time be negative 10 seconds in this problem? No, what's the lowest that the time could go?
0.
Yeah, it won't go any lower than 0. What's the highest the time could go? Well, that's the amount of time it takes for the rocket to come back down and hit the ground. I don't know how long that is. I'll just leave it at 10 seconds. Y is the height of the object. Could the height of this object be negative 100 feet? No. What's the lowest the height could be? 0, because it was from ground level. So the lowest it can go is to come back on the ground. How high does it go? I don't know. I'm just going to guess 100 feet. If it goes higher, well, I'll look at it. It actually looks like it comes back down to the ground in 4 seconds. Okay, so what is the maximum height? And when does it reach that height? Okay. What do you think I'm looking for in that graph to figure out the maximum height? Yeah, I'm looking for right here. I want to know the coordinate of that point, top of that parabola. Okay. Finding it by hand, we can do, but I'm going to show you how to just do it on the calculator. You're not responsible for doing it by hand. Yeah, question?
I was going to say, can you just give report?
So yeah, it is usually, if you know this point and this point, it is right in the middle, but we also have to figure out how high it goes.
Okay.
So it is going to be at 2 for the x value, but now I need how high it goes. So the way you can find it is press second, and then press calc. And one of those options is going to tell me how high it goes. Anyone have a guess which option? Yeah? Yeah. So I'm just going to go to option 4. I just press 4. And the calculator will ask me 3 questions. First thing it says is to pick a point. I'm just going to keep pressing left till my cursor shows up. That is somewhere to the left of the maximum. Good enough. So I need to move my cursor so it's to the left of the maximum. Hit enter. Then it says right bound. I need to move my cursor to the right of the maximum and hit enter. What I've done now is I've given the calculator kind of a zone it's going to look in. Right? It's going to look between those two lines. And the last thing I have to do is the guess. The guess doesn't matter. You can really just hit enter. It is used for other things, but in this problem it has no effect. So just hit enter. All right, let's look at this. So remember, this is time. This is height. So how many seconds does it basically take for this object to hit its highest point? 2, right? It's saying 2.000000. It's 2, all right? It's 2 seconds. So we're going to round that. So after 2 seconds, the rocket hits. Now, what's the height of the rocket at 2 seconds? 64. That's how you find how high the rocket goes. Now, it doesn't hit 64 feet twice. That's the only point in the parabola that it won't hit twice. So 50 feet might be like right there. Hits it on the way up and on the way down. But 64 feet, it just hits it and comes right back down. All right, so any question on how we use quadratic formula for the first part, and then how I use the calculator to do the second part? All right. Okay, last thing. So the last thing is it's just typing something in on the calculator. And it's what we call a piecewise function. When we type in a piecewise function, we're basically just graphing two things at the same time. That's all it is. So let me give you an example of how the domain could be split into several parts, and then you have a different formula for each part. Let's say that I'm selling tickets. If you are under 6, tickets are $5. If you're between 6 and 18, tickets are $10. And if you're over 18, tickets are $15. So what I've done there is I've taken the age of people and I've broken it into 3 sections. Less than 6, between 6 and 18 and older. And I'm using a different formula to calculate the price of your ticket depending on how old you are. That's an example of a piecewise function. And it doesn't just have to be about age. It's just you use a different formula for different parts of the domain. So here's a piecewise function. That's how you write it. It's 2 different formulas. One formula is used under certain conditions. The bottom formula is used under other conditions. So let me just make up a number. Let me say I wanted you to plug in 0 for x. If you plugged in 0 for x, you first have to look at, okay, is it the top or the bottom formula? Anybody think they know which formula you would use if you were going to plug in the number 0? The bottom one? How come?
That isn't like 0, like square root, cubic, always 1.
Well, the formula you use depends on what comes after the if. So they tell you to use the top formula if x is less than 1. And they tell you to use the bottom formula for any number 1 or higher. So if I was going to plug 0 into that, what formula would it get plugged into? The top one. And what would be the answer if you did 3 minus 0 to the second power? Yeah, it'd just be 3. Okay, what if I wanted to plug in 2? And I said, tell me the answer when you plug in 2. Would you plug 2 into the top formula or the bottom formula? Yeah?
Is the bottom?
Yeah, why the bottom one?
Because the thing is like facing towards the x, so it's the x is like greater.
Yeah, so 2, because the bottom one, it says to use that formula when x is greater than or equal to 1. I said plug in 2, and that's greater than or equal to 1. So you plug it in there. What if I said to plug in 1? Which formula would you plug that one into?
The bottom one?
Yeah, because the top formula is only supposed to be used when x is less than 1. 1 is not less than 1. So it's just a different formula you use depending on the value you plug in. Okay? In this case, it splits it out 1, higher than 1 and lower than 1. It doesn't have to be 1, it could be a different number. All right, but what I want to show you is how you type that in. So typing it in, very similar to how we type in other graphs. The only thing we have to do is we have to put in parentheses. So when we type in 3 minus x squared, I want you to type it in just like that. Now, if that's all you do, just type in 3 minus x squared and you press zoom 6, it's going to draw that graph on the whole screen. But I want that graph to stop at what number? Where does it say that this formula should be used up to? Right up to what number?
1.
It should only be used up to 1. Okay, so what should happen is this part of the graph from here on shouldn't be there. It should draw it up to 1 and then just stop. Okay? So to make it do that, we have to tell it this condition. So in parentheses, on the end, we're going to tell it to only draw that graph when x is less than 1. So we press x. And now we have to type in the less than symbol. Okay, I don't think I've shown you where the less than symbol is yet. The less than symbol is under second, and then press math. Second, and then the math is the third button down on the left-hand side. That's how you get to your inequality symbols. So we want the fifth one. We want a 1. Close the parenthesis. Okay, anybody have trouble finding the symbol? All right, let's hit graph now and see how it looks. And that's as good as I can do. So we technically don't want this part on the axis. I can't get rid of that. But you can see it does stop at 1 now. And that's what we wanted. Okay, the horizontal part, just pretend that that blue's not even there. All right, so that's the first one. And we're going to do the same for the second one. Type in x to the third power. Once you type in your exponent of 3, if you keep typing, it's going to stay in the exponent. If you press the right arrow, it drops you back down to the regular. So it's not in the exponent. Okay, and for this graph, where do we want this one to start? We only want it to draw that graph when x is what?
Greater than or equal to 1?
Only when it's greater than or equal to 1. So we're going to put in x, second math, option 4, and 1. So now when the blue one stops, the red one should start up.
How do you get the x3 again?
You press the button right below clear, and that'll give you the exponent.
Okay.
Now, when the blue one stops and the red one starts, they might not be connected. The red one might start down here and then do something like that. Okay? Let's take a look and see what it looks like. Okay. So that is what our graph should look like. How many people got something that looked kind of like that? This part that's in the middle, I'm just going to trace over it in black. Pretend like that's not even there. Okay, there's no way for me to get rid of that either. So that's called a piecewise function. It's two different graphs drawn at the same time. Sometimes these pieces line up and connect, sometimes they don't. In this case, they don't. Any questions on doing that on the calculator? Where to find inequalities, anything like that? All right, so that's pretty much everything in 1.3. Let me put the homework up again in a second because I might change one question. Let's see. Page is good. So we're just going to. So that's the homework for tonight. So 3 to 19 odd. And then 24, 32, 33, and 45. Okay, so we'll take a look at that tomorrow. And then don't forget on Thursday we have a review day. Second test for the term will be on Friday.